Okay, this is a quick summary of how we can evaluate higher powers of I. So we already know that I to the first power is equal to the square root of -1. So it's just I. Similarly, we've talked about I squared is equal to -1. And the reason for that is because that's the square root of -1 squared, and that gives us -1. Now, if I take I squared and I multiply that by another I, then I'm going to get I cubed. Well, if I know that I squared is -1 and I multiply that by I, then that means that I cubed is -1 times I, which is -I. That doesn't really simplify down to a real number, but it is simpler than I cubed. And then if I take that I squared again, and what if instead of multiplying it by I take I squared times I squared? Well, that would mean that I'm doing -1 times -1, which would mean that I to the fourth is equal to +1, because that's -1 times -1. Okay, so here's what we know so far. We have I squared is -1, I cubed is -I, and I to the fourth is +1. Now, what if I multiply that by I again? That would make it I to the fifth, and that would be 1 times I, which is just I. So I to the fifth would bring me back here. It'd be the same as I. If I multiply that by another I to the sixth, that would be I again times another I. It's just going to repeat. All of these are going to be equal over and over and over again. I to the ninth would be the same as I again. I to the 10th would be the same as I squared again. It's always going to follow this pattern. And what it comes down to is, since I to the fourth is always equal to 1, I can think of I to the fifth as I to the fourth times I. Well, this is just equal to 1, so that's why this is the same as I. I to the sixth is going to be I to the fourth times I squared. This is just equal to 1, and this is equal to -1. That's why we always want to take that I to the fourth out, because it's equal to +1. So here's really how this comes out to be. It's one big cycle, okay, that repeats over and over and over again. We start with I, we go to I squared, we go to I cubed, and we go back to I to the fourth, and then it restarts. And each of those values is I, -1, -I, +1, and then it repeats and repeats and repeats again. So what we need to figure out for any higher power of I is we need to figure out how many complete cycles of 4 have we finished. So we want to figure out what is the remainder, okay? So if I wanted to know, for example, what is I to the 37th power, okay? This is the question we're trying to answer. I to the 37th power. I need to think to myself, how many times does 4 go into 37? And I want to know what's the remainder. I don't actually care how many times it goes in, but I know that 4 goes into 37 9 times exactly, because that's 36, with a remainder of 1. This is what I care about, is a remainder of 1. A remainder of 1, that's I to the first power. That tells me that my answer is going to be I. I to the 37th is the same thing as I, okay? So if that circle isn't a way that you like to look at it, some people like to think about it that way. I prefer a list. So I have I have I squared, which is -1, I cubed, which is -I, and I to the fourth, which is +1. Here's what we want to be looking for. Sorry, that's incorrect. Remainder 1 is equal to I. remainder 2 is equal to negative 1, remainder 3 is equal to negative I, and you can see that corresponds to the exponents, I to the first, second, third, but I to the fourth is going to actually be a remainder of 0 because that's 4 complete cycles. Every time you've completed a cycle of 4, you land on positive 1. So that's always kind of what we're looking for. This is how I like to remember it. If you like to remember it as a circle, this is remainder 1, remainder 2, remainder 3, remainder 0. And it just repeats that circle. So let's think about another one. What if I wanted to figure out I to the 42nd power? Divide that by 4, think about what the remainder would be, and see if you can figure out what that would be equal to. I to the 42nd power. 4 goes into 42 10 times, because that's 40. So there's going to be a remainder of 2, which means that's going to be equal to negative 1. That's how we would figure that out. Figure out what is the remainder. How many times does it go in evenly, and what will be left over? The remainder is what we care about when we divide. And so these are the answers we're looking for. It's either going to be equal to I, negative 1, negative I, positive 1. Those are the answers we're looking for. Okay? So that's how you evaluate higher powers of I.